Welcome to The Explainer. We're here to take complicated stuff and, well, make it simple. Today, we're talking about OpenCV.
So let's just jump right in with a huge question. What if computers could actually see? I mean, really see. Not just process colors and shapes, but look at a live video and understand what's really going on?
This isn't some far-off sci-fi idea. It's happening right now, today, thanks to a tool called OpenCV. From the camera app on your phone to the super smart robots in a factory, OpenCV is the free open-source engine that's literally teaching machines how to see.
Okay, so what is this thing, really? What is this library that's giving machines the gift of sight? Let's break it all down.
The name pretty much says it all, right? Open-source computer vision library. Think of it like a free universal toolbox that's just jam-packed with everything a developer needs to work with images, video, and even machine learning. And wow, has OpenCV had a journey. It actually started way back in 2000 as an Intel project, just to see how far they could push vision research. But today, it's not some corporate thing anymore. It's a global standard built and supported by a huge community of developers all over the world.
To really get how this works, we've got to start small. I'm talking about the most fundamental level, the tiny little pixels that make up every single digital image you've ever seen.
So, at its very core, OpenCV gives developers total control over every single pixel in a picture or a video. And that's where it all begins, really, by playing with these little dots of color.
For instance, a really simple workflow could be, reading a photo, maybe slapping on a sharpen filter to make the details pop, cropping it to focus on your subject, and then just saving the new version. This kind of fine-tuned control is the foundation for all the really complex stuff.
First, it loads a pre-trained HAR cascade model for face detection. Then it opens the webcam, reads each video frame, and converts it to grayscale for better detection. The model finds faces and draws green rectangles around them. The video with detected faces is shown in a window, and you can press Q to exit.
And that foundation opens up a whole world of possibilities. You can do the simple stuff, sure, like resizing and cropping, but you can also do way more advanced things like detecting the sharp edges of an object in a photo, or even tracking a soccer ball as it flies across a field in real time.
But look, just messing with images is only the beginning. The real magic happens when the computer starts to actually recognize what it's looking at.
You've seen this a million times, right? Every time your camera app puts those little boxes around your friends' faces instantly. That's not magic. It's computer vision, and a lot of the time it's powered by libraries just like OpenCV.
So how in the world does it work? Well, it's all about pattern recognition. OpenCV uses models that have already been trained to find what they're looking for. A classic way to do this is something called HAR cascades, which is kind of like a super fast checklist for the computer. It scans for simple patterns, like a dark spot for an eye next to a lighter area for a nose. Combine thousands of those little checks, and bam, it can spot a face.
And it is definitely not just for faces. You can use the exact same idea to find pedestrians on a street, cars on a highway, or even the eyes of a driver to see if they're getting sleepy. This flexibility is what makes it so incredibly important for real-world stuff.
And it's this exact ability, not just to see, but to recognize, that's fueling the whole AI revolution that's happening all around us.
So let's go back to that starting date for a second, the year 2000. It's honestly kind of mind-blowing how far we've come since then.
I mean, think about it. That simple library from back in 2000 is now a key part of some of the craziest tech we have. It's helping self-driving cars see people, helping doctors find tumors in scans, and letting warehouse robots pick out the exact right package.
And that's the main takeaway here. OpenCV is the bridge. It's the thing that translates all those raw, meaningless pixels from a camera into information an AI can actually use to make smart decisions.
So, with all the tech out there today, why? Why has OpenCV become such a powerhouse in the world of computer vision?
Well, it really boils down to three main things. First, it's cross-platform. You can write your code once, and it'll run pretty much anywhere, from a huge server to your little smartphone. Second, it supports languages like Python and C++, so developers can just use the tools they already love. And finally,
performance. It is blazingly fast. And that's not just a nice little bonus, it's absolutely essential for anything that needs to process video without any lag. So you've got this incredible combination. It's free, it's fast, and it's flexible. I mean, that's the winning ticket right there. It's why it's the go-to choice for absolutely everyone, from students just starting out to pro teams building the next generation of AI. Which leaves us with one last question to chew on. Now that we have tools like OpenCV giving machines a clearer and clearer view of our world, the real question becomes, what do we want them to see? And maybe more importantly, what will we teach them to understand